Okay, so we've been looking at factoring, and there's a couple special types we looked at. My last video was on factoring things that had 4 terms. Let me show you what I'm going to show you now. Let's get you to see. So what I'm going to be working on now is over here. You get it in red. Okay, so now I want to work on how to do things that are cubes. Sorry, let me turn my TV off. Okay, so one thing people kind of like about this is these involve formulas, and here are the formulas. And so there's no guessing or checking. It's a matter of just properly using the formula, okay? And I'll share with you what the hard part is. If you'll just really work at it, you'll be fine. All right, so what we're doing now is we're factoring. Okay, this video covers factoring, and it covers factoring sums or differences. I didn't spell that right. Oops, really messed it up. Let me try again. Factoring sums or differences of cubes, okay? Like, and we'll do all of these, like x to the third minus 64. Both of those are perfect cubes. Or maybe x to the third plus y to the third, or maybe something like this, 8x to the third plus 27, okay? So we'll do 3 examples on that. All right, now these involve formulas. So the second you notice that something's a cube, okay, and you realize, oh, it really is a cube, there's not like a common factor or anything like that, then you go and you look up the formulas. So you know the formula for the sum of cubes, and you'll be given this. You don't have to take time memorizing it. Here's the formula. And for the difference of cubes, it's very similar. It just starts with minus between those and then turns into plus. There's the formula for the difference of cubes. So difference and sum of cubes. So you look and you say, first off, you ask yourself, is there a common factor? But there isn't one. Then you say, oh, but this one involves a cube, so I need to go look for the formula, and here it is, okay? And so what you should be thinking based on that is that you need to see what got cubed in each case, and then the formula says you're going to take the first minus the second, okay? Then it's going to be the first, well, we'll do this when we get to it, but oops. It's going to look something like that. It's going to be 2 terms and then 3 terms, okay? Here's the place that people mess up the most, right there. This is the hard part. If you can understand this, you'll be good to go. You need to think about what actually got cubed to make x to the third. So that's just x. Then what actually got cubed to make 64 would be 4. So the formula tells us that this would be, so this is like your A, this is like your B in the formula. So it says this is your A and this is your B. Formula says do A minus B, then do A squared plus A times B plus B squared. So if A is X, we put an X. Then we have minus B is a 4. A squared would be whatever X is squared. Then take your x times your 4, but you do typically write the number first, so I'll flip that around. Then take the b, which is 4, and square it, okay? And then you just clean it up a little bit, and you'll be done. Now, what you're going to think is that you might need to factor again. So actually, if you think that, you're actually a pretty good factorer. But because that's a squared, you might think you need to factor again, but it turns out this middle term always turns out to be half as big as it would need to be for that whole thing to factor. That would need to be an 8 in order to factor. So it's okay if you think that, but when you put in an x and an x and a 4 and a 4, you can't make the middle term of 4x happen, okay? So after you do that enough, you have to trust that if this part of the formula, see, I went back up here to the formulas. If that part of the formula would break down again, they would have written it that way. So this is the way your final answer would look. Okay. All right, let's try another one. We do this one in blue. So this one says x to the third plus y to the third. So when I'm thinking about my formula, x actually did get cubed and y actually did get cubed. So x is my a and y is my b. Formula says it would be 2 terms and then 3 with x, y, and a plus. Then I would take the x and square it. Then I would have minus x times y. Then I would have plus the y squared. So I'm just looking at this formula right here. And I'm replacing the a with x and the b with y. There's no guessing or checking. This would be my final answer. Okay. All right, let's try 8x to the third plus 27. Let me move that over just a little bit. So that was 8x to the third plus 27. This one I wanted to do because the hardest part is that first step. What really got cubed to make 8x to the third? What really got cubed to make 27? A is not 8x and B is not 27. That's the hard part. This is the hard part. So you see, to get an 8, you would need to take 2 times 2 times 2. To get x to the third, you would need an x. So this is really your A. That's the part I want you to ponder. Okay? Then with 27, it's 3 times 3 times 3. So 3 is your B. 27 is not your B. Okay? Now, once you know that, then that's the part that you need to know. Then you're just plugging it into a formula that says you're going to take A plus B, take A squared minus AB plus B squared. So you're going to take 2x plus 3. Then you're going to take, and here, people do mess up here. This is another issue. You're going to take the 2x and square it, and that does not say to take the 2x and square it. You need to think 2x has to be squared. Okay. Then minus 2x times the 3, then plus the 3 squared. So this is one hard part right here. The other hard part is this right there. Okay. So you think about how that first term needs to turn out to be an 8x to the third. If you mistakenly just put 2x squared there, that 2x would get multiplied by the 2x when you go about distributing, and it would only give you a 4. You need to get an 8. So it's really important that we work on that. This would need to be a 4. If you really want to understand it, you got to understand why that needs to be a 4. It's because A is the whole quantity 2x. And when 2x gets squared, you wind up with 4x squared. Then this would be minus 6x, and then 3 times 3 would be 9. Okay, see the thing is, this, whatever we write as being the factored form of the original problem, would mean that if I took the time to distribute like this, then I ought to get 8x to the third plus 27. Okay, so here would be the check. This really takes a lot of time, so I don't normally do it, but if I just want you to see it. So I'm claiming that this factored form of the original problem is right, but watch, if I took the 2x and I multiplied it out like you did on your chapter 4 test, wouldn't that be 8x to the third minus 12x squared plus 18x? Then you'd come back and you take the 3 throughout, and when you get a plus 12x squared, a minus 18x, and then a positive 27, see how that would be 0 and that would be 0, and we would wind up with just 8x to the third plus 27. Okay, so that just tells me, yep, I was right. But your final answer is this. All right, and you might be tempted to try to factor 4x squared minus 6x plus 9, but no matter what you tried here, 2x and 2x, 3 and 3, your middle term would always turn out to be half what it needed to be. This would never factor. If it did factor, the formula would have gone ahead and be, instead of being written the way it is, they would have gone ahead and written it more factored. Okay. All right, so that's that. Just want you to take a look at factoring cubes, sum and difference of cubes.